Welcome back to the morning show. Coming up on 6:50 on Wednesday. That only means one thing. We give Matt 3.5 minutes to wow us with his scientific knowledge.
Uh-oh, well, you're not going to be disappointed. I was thinking last time, remember, we talked a little at the end about heat engines.
Sure.
And we had this funny thing where you just had the heat of your hand and it made it go up and down. And the whole operation of those is kind of based on the fact that if you have a gas and you heat it up, the gas will expand. And as it expands, it cools off again.
Sure.
Okay, that's how an engine works. So if you have an explosion in the gasoline in your cylinder, when the cylinder is really cramped, the cylinder opens up, and then the exhaust gas is a lot colder than the gas was during the explosion.
Is that why my check engine light's on right now?
That's a bad sign.
Just kidding.
And anyways, that thermodynamic principle can be used to make things cold. Because if you start with gas that's compressed, but it's already kind of cold, if you increase the volume of that object, if you allow the gas to sort of push and make itself larger, it's doing work, but that energy has to come from inside the gas, and the gas cools off. So if you may have felt this, if you ever let like the air out of a tire on your bike or in a car, the air that comes out will feel cold. And it's not just because it's blowing by your hand, it's because it actually is colder. Or if you have an aerosol can, sometimes if you just spray the stuff on the inside, when it comes out it'll feel cold. It's because of the same principle. An expanding gas, if it's pushing things out of the way, will become cold. So you can use this fact with a very common gas that we all know, which is carbon dioxide. And so here's a fire extinguisher, and if I just kind of let this thing go, I'll see you.
Ready out?
Okay, so what I'm going to do is stick this in here so I can catch whatever happens to come out, because carbon dioxide gas, when it expands, will be colder and will become a solid. Oh, you know what? Okay, you have to pretend there's something in there. Oh, look, there's something in there.
Wow.
Well, what happened? Okay, so I think the cylinder I got was kind of running low. So if I had a brand new cylinder, we would have had like snow forming in there.
Oh, I see. Well, it just made one big clump.
Yeah, well, what we did was I cheated. I threw that in there. But what you get when you do that is you get a solid carbon dioxide. And it has some really interesting properties, which is that carbon dioxide at regular pressure like we experience here on Earth, when it doesn't melt. It goes directly from being a solid to being a gas, which is why it's called dry ice, because it doesn't have wetness. It doesn't melt into a little puddle, which then evaporates. It just goes from being a solid to being a gas, which is called sublimation.
Okay.
And so there's kind of lots of fun things you can do with this, but let me just, since we probably have, what, 20 seconds left?
About a minute. Less than a minute.
So I can show that this is carbon dioxide. I can just drop it in my coffee, or better yet, I'll drop it into the water. This little piece of dry ice, which I should have made, but which I actually got from the cup over here. I brought a whole bunch with me. You'll notice when I put it in the water is much hotter. The dry ice itself is about 80 below. Celsius, and so that's why dry ice is used for making ice cream or storing blood products, things like that. You can buy the stuff at the blood bank. But if I put it in water, which is a lot warmer, that sort of accelerates the evaporation of it, and so you get a lot of carbon dioxide gas.
It's like a Halloween brew.
Yeah, so what you're seeing here isn't carbon dioxide. You're seeing water vapor, and it's just sort of like fog, because there's a little water vapor above the water in this thing. And so the white stuff is sort of where the carbon dioxide is. And carbon dioxide is actually heavier than air, so it'll stay in that container till I pour it out. And since carbon dioxide just displaces oxygen, it just pushes air out of the way. If I pour it under the match, it'll put the match out. Okay.
Very cool.
Okay, so anyways, the fact that this thing boils and the fact that this stuff sublimates is interesting, and when we come back, I'll show you how you can make like a little air hockey thing out of it.
Oh, cool.
Okay, and maybe we'll blow something up. I don't know. We'll see.
Always sounds good. 7:25. Be sure and stay tuned to that. 6:53 now. Let's check in with Amber.
Well, thank you, Raw. We are taking a live look at Center Prairie Heart Institute Champaign